And finally, number 14, part A wants the area of this region here. This curve is y equals root x. This one is y equals x over 3, which is the same thing as 1/3 x. It gives us the intersection points. So we need to integrate from 0 to 9 of the top function minus the bottom function. Top function there is the root x. Integrate from 0 to 9. Plugging in 9, I've got square root 3, cubed is 27, divided by 3 is 9, times 2 is 18, minus 81 over 6. I can divide the top and the bottom by 3 here, so 27 over 2. Common denominator is 2. 9 over 2. Part B wants us to write an expression that would find the volume when revolved about the horizontal line y equals 4, which is right here. So y equals 4, that's a horizontal line, so we are using the disk method. We are going to go all the way across. So it's pi times the integral from a to b of this radius squared. And that distance starts at 4 minus this y value, which is 1/3 x. And then we need to take out the volume that is created from going from here to here. That's going to be the empty space. So minus 4 minus this curve, which is root x. And then finally, part C asks us to write the perimeter of R, write an expression for the perimeter of R. You could use the arc length formula twice. Since this one here is a straight line, usually you won't see this part written as an arc length, as an integral. So that distance, we can set up a right triangle here. This side's 9 and this side's 3. So 9 squared plus 3 squared equals the side I'm looking for squared. So c squared is 90, so c is 3 root 10. So that's the distance of the straight line. We need this distance of the curve also. So we've got that 3 root 10, and we need to add the distance of the curve, which is going to be the integral from 0 to 9 of the square root of 1 plus the derivative squared dx. And I'm looking just for this curve. So that curve is this guy. So the derivative of that would be 1/2 x to the negative 1/2. Squeeze it in there. And there we go. That would be the arc length that tells us to write but not evaluate. We are finished.